So today we'll discuss regarding the Kubernetes. We have the probes and network policies and resource quotas. So what is the concept of probe is? Assume in the microservices, you may have some thousands of pods are running. Each and every time, like maybe checking the parts, those are little challenging kind of thing. Then we are going to give some kind of self-healing kind of capabilities by using the probe. So can you tell me what is the meaning of self-healing is? If something goes wrong, automatically that itself need to repair it. Okay, so for that purpose, we have the probes. So what are the probes we have will discuss? We have three types of probes. One is liveness probe. What is that? Liveness probe. Readiness probe. Startup probe. Say, what is the concept of liveness probe is? So what is the meaning of liveness probe is? Assume if any of the pod is struck or deadlocked, it's not working. It's struck. It has been struck or deadlocked. Automatically, liveness probe will restart the pod. Okay, even if you go also, you are going to try to restart that pod itself. But on behalf of us, who is going to restart?
Liveness probe.
Liveness probe. If you configure the liveness probe, what is the advantage is? If any of the pod has been struck or deadlocked, automatically the liveness probe is going to restart the
Pod.
Liveness probe is going to restart the pod. Okay, so then we have one more is there, readiness probe. Okay, say pod is ready. If pod is ready, then only if the pod is ready, then only.
It will start the pod, sir.
No. Service okay, say if the pod is not ready, then the service is not going to send the traffic to that
Pods.
pod. With this, what is the advantage?
It will act as a load balancer, sir. It won't.
Yeah, actually, internally, service itself act as a load balancer also.
Yes, sir.
And it is checking the health check also through the readiness probe.
Yes.
Okay. And if the pod is not ready, then the service is not going to
Redirect the traffic, sir.
redirect the traffic to the pod. Okay. So then, what is the concept of startup probe is? If the pod is taking more time to start for first time, okay, so pod is taking more time to start for the first time, then normally readiness probe won't restart. Readiness probe, what it will do is, it would be removed from the load balancing. Okay, if the readiness probe is failed, it will remove from
Load balancing.
service load balancing. Okay, so readiness, if the pod is taking more time to start for the first time, then liveness probe or readiness probe may be restarting the assume for every 5 minutes, if my pod is not responding, I want to restart that pod. That is the liveness probe. But for the first time, my pod is taking 10 minutes, assume. Then each and every time Lioness probe, what it will do? It is trying to start, but Lioness probe again will
Restart the pods.
start. So then, if we enable startup probe, can you tell me what is this difference? Okay, if we enable startup probe, it will suppress.
Liveness and readiness probe.
That means for the first time, if the pod is taking more time than expected, then it's recommended to. It's
Go
recommended
for
to
startup probe, sir.
yeah, startup probe. Then what happens? Liveness probe and readiness probe doesn't work for
Startup probe, sir.
for the first time. It won't work. For the first time, it won't work.
Won't work.
Okay, so later, once it is started, again, Linus probe and readiness probe will work. Do you understand?
So can you please explain this once again, sir? Startup probe.
See, assume my pod is normally all the pods are getting started for 10 minutes only. Sorry, 5 minutes. Okay, so remaining all are getting started for 10 minutes. Then Linus probe, if I configure, if the pod is not responding for 5 minutes, restart that pod. Okay, then it's continuously restarting the pod. Then the pod never starts.
Okay, it will keep on restarting in the loop, right?
Restarting the pod. But if I enable this feature, startup probe, for the first time, it won't work. Liveness probe and readiness probe, it won't work for the first time. That means when the pod is getting started, those two rules doesn't work. Are you able to understand? Are you able to understand?
So, sir, this means that it will hold on both the process, right?
Actually, the probes doesn't work at the time of startup only. If I enable startup probe also in the pod.
Okay, sir.
Okay, so liveness probe, readiness probe, when they work,
They will restart.
but if I enable startup probe will suppress them because first it will give the priority to start the pod.
Oh, okay. I understood, sir.
Okay, for all the parts, we no need of this. If any of the parts are taking more time than expected,
Then we'll trigger this startup probe.
then enable startup probe. Otherwise, what happens is it goes to a deadlock kind of situation. Pod is trying to start, it's taking more time. Then again, Linus probe assumes it's not starting. Then again, it restarts.
It will keep on restarting
It's
and
keep on restarting. So that
and
is
if it starts luckily, then this
for
readiness
the
probe
first
will
after the
activate.
first time it started, then it goes for liveness and readiness probe also.
Okay, understood, sir. Understood.
Okay, so these all like something kind of self-healing kind of features. For this, we need to enable the
Services.
in the Helm chart itself. We can specify these all. Like we'll have the scripts, all those running. So what are the types of probes we have?
3 types of probes.
The 3 types of probes. So, try to read all this complete documentation also. The Kubernetes is a vast thing, not in 7 days or 10 days, not like that. Even for next 1 year also, you should be learning this. But more job market has been for the Kubernetes. Hence, try to get more knowledge on Kubernetes itself. Okay, so liveness probe is used to when to restart the container. Okay, so then restarting the container may help to resolve that issue. That's the reason it's trying to solve. If even it's not solved, then manually we need to troubleshoot it. But thousands of issues may be going to this state. Instead of having again an administrator help, it maybe keep on restarting. And with the readiness probe, always the application to the end user is available, which is a healthy one only. Because if it is ready, then only like readiness probe is allowing the user to connect to
That specific pods.
that specific part. Okay. And at the time of startup, if it is taking more time,
It will suppress both
then
the
it will
services.
suppress those. Okay. So in the same way, we have network policies also. So in the AWS, we have security groups, right?
Yes.
Okay, say by default, I want to access only some range of IP address. I don't want to allow, say, suppose I have some of the backend parts. I want to allow only from my database related services itself, or from web server to only from this range of parts, IPs only I want to allow. If you have these kind of rules we required in the parts internally, then we need to use the network policies. Okay, so what is the meaning of ingress and egress rule is nothing but inbound and
Outbounds.
outbound rules. So these kind of rules we can apply through network
Network
policy.
policy.
So we can apply these through network policies. And if we want to allow the multiple namespaces also, for that also we can use. You want to block any IPs also within the pod, there also we are going to use
Namespaces.
network policies. No, between two namespaces, I want to allow the traffic or restrict the traffic.
Okay.
Okay, so these all that we need to identify based on the network policies. So now this is what is the meaning of ingress here?
Inbounds.
Yeah, allow traffic. Normally here ingress rule means inbound rule. Egress means outbound rule. So in this only from 172 series only.
Is allowed.
Yeah, but in that also one-sider they're not allowing.
Yes.
And which namespace they're allowed? Only my project. This pod is allowed from only
My project.
my project namespace resources, and that IP range is
172.17.00/16.
yeah /16. In that also 1.0 subnet they have excluded.
Yes.
Okay, if you have these kind of specific requirements, then we need to go for
Network policies.
the network policies. Okay, so we need to create in the pod itself, we are going to create the network policies also. And here network policy and pod has been attached based on, you need to tell. Go through the YAML file, network policy and pod has been attached based on what? Network
Names.
policy and pod has been attached based on
Names.
what name?
Metadata names.
Hmm?
Metadata name.
Yeah, based on the, here we have the pod selector, right?
Yes. Yes.
Okay, so that means which of the pods having that label to that parts, this network policy has been attached. Are you able to understand?
Yes.
So what is the concept of network policy? From which IPs you want to allow, okay, and from which namespaces you want to allow. So these kind of things we can design through
Network policies.
network policies. For that, we are going to create the network policies. By default, most of the part to part within the clusters, the communication is going to happen. But if you have any specific requirements to restrict like that, then we need to go for that. Then for that, we need to go for these resources. Okay, so probes also something helping, and restrictions, those all we can done through. And one of the reason I said to go for namespaces is we can say we have 3 teams of people. I can assign like resources for them. So what is the concept is I want to allocate the resources. Okay, say I have 4 nodes, each node having the 4 CPUs and 16 GB RAM. Then total I have 16 virtual CPUs and 64 GB RAM. These all I want to allocate the resources. For dev namespace, I want to allocate 4 virtual CPUs and 8 GB RAM. For QA also same. Remaining for production. For production, eight virtual CPUs and around 32 GB RAM I want to allocate to
Production.
production. That means if I don't create the namespaces, dev and QA also will consume
The same space.
more resources. Okay, then production workloads will get shortage of resources or not.
Yes, sir.
That is the purpose we created. By only creating the namespace, it won't allocate the
Resources.
resource quota. Okay, so then we can allocate the resource quotas by creating those. Okay, so we need to create the resource quota and attach that resource quota to
Our network policies.
no namespaces. Attach that resource quota to
Namespace.
namespace. So that is the purpose we are creating the namespaces. So for storage, we can give otherwise how many ingress resources we want, how many that team, how many they can create, all we can specify here. Okay. So for persistent volume climb, dev team, I'll give only 10 GB. More than that, they can't use. How many deployments they want to create, all those I can control by creating the resource quotas. So in this, how many CPUs we given?
5.
5. Parts are
10.
10. Memory is
10 GB.
10 GB. Okay, here I given 10 and 20 GB. So 3 resource quotas I given. For dev, maybe I may give this one. Parts high. Okay. For QA, I may give parts medium. Okay. Low priority I'll give for dev environment. Once I create this, later I'll attach these two to the namespaces. See here, while creating that hyphen namespace equal to maybe production you want. Okay, QA you want. So like this, we can allocate the
Resources.
like namespace. Then that quota has been assigned to, and if we exceed that quota, then in that namespace, it won't allow us to create that resources. If that quota has been exceeded, then we don't get more resources, we can't create. So now here we created one namespace called as quota object example. Okay, then how many they given the resources? They can create only one persistent volume, two load balancers, and no node.
Zero node.
Okay, then this has been attached to this resource quota has been attached to the namespace quota object example. Then if these resources try to create okay more persistent volume claims, okay, that's not getting created. So this is still in the pending state itself. Or maybe if the second created, we got an error. What is that error we got? Because we given only one PVC client they can use. But now they're trying to create second one. Then we'll get a forbidden kind of error. So with this, we can restrict the users by creating unnecessary resources or more than their usage kind of resources or not. That kind of
Yes.
quotas we can configure using that kind of quotas we can configure using resource quotas. So using the resource quotas, we can configure these kind of settings. Any doubts? Not only for CPU, memory, for any of the resources also we can specify the quota. Again at the part level also for CPU and memory we can specify the limits and requests. So now this is at the namespace level. For the parts also we can assign that. Okay. Then we'll go for one more resource. Config map. Okay. So why we'll use config map and secrets we'll discuss. Config map. So why we'll use the config map is we have three environments. So I have dev, QA, staging. I want to pass dev settings for dev environment. So remaining all the pod and container all are same, but only some application settings or environment settings for dev settings are different, QA settings are different, staging settings are different, or maybe production settings are different. For this, again, creating three pod specifications is very tough to manage in the real time. Then remaining all the pod details are same. Only whatever the settings we have, those we are going to pass them as config map. Okay. And what is the difference between config map and secret is purpose is same. Non-sensitive details we will pass as config map. Sensitive details will pass as
Secrets.
secrets. Can you tell me some of the sensitive details?
Like
Like maybe
passwords.
passwords. In English, we use the certificates, right?
Yes.
Termination. Otherwise, like maybe we have SH keys. So these kind of sensitive details, if we have, then we are going to use
Secrets.
secrets. So what is the purpose of this is, if we have multiple environments, for those environments, we are going to pass the values through secrets. So we are going to pass the values through secrets. Okay, so for dev environment, I have my different settings are there. For QA, I have different settings. Okay, so like this, we have the settings, then we are going to use the
Config maps.
config maps. So here we need to create a config map resource, and in the pod, we are going to pass that config map. So non-confidential details in the key value store, we are going to store. Say for assume in this DB host for dev environment is different, QA environment is different, for production is different. If I keep this information in the container itself, it would be very challenging, because for the three environments, I need to create again three different containers and three different Docker files. So that is the reason it's not recommended to keep those images in the container also. We need to pass as so here these all the properties. So these all, you no need to worry. These all their application properties. What is the values? They said 5. For production, I want more. Okay, then what is the name of this config map? Game demo. For game production, these values may be player initial lives, maybe instead of 3, they may have 10. Like this, these are the different values. Okay, I'm going to create with this application settings as one config map. In our scenario, if I have 4 environments, can you tell me how many config maps we need to create? How many config maps we need to create? 4 config maps we need to create 4 different settings. Okay, 4 config maps we need to create for 4 different settings. Is it fine? Okay, so in this example, what is the name of the config map? Assume game demo is there, but instead of this game demo, assume game dev. For dev QA, these data settings may be different. Okay, so once you create like this, the config map, once you create the details like this as config map, here the value from where we taken this.
Game demos.
Yeah, if it is for production, you need to only just rename that game hyphen demo to game hyphen
Prod.
production. Yeah, if it is QA,
Game QS.
yeah, player initial lives in the demo environment we have 3. For production, that value may be 10. Then here this key has been attached to this value. Based on the config map values, it is going to pass those details. Are you able to understand? So here player initial lives, here that is one of the variable. In this we given the value is
3.
okay. If it is my DB host, that host name I'll give here. Okay. So then for dev, what is the value is there? That value would be taken. For production, what is the value is there? That would be considered. Like this, if it is a non-sensitive details, we are going to store them as config map. If it is a sensitive details,
Secrets.
We are going to store them as secrets. Okay, so today we discuss probes, like what are the probes we have? So what are the probes? Liveness
Three
probe,
types of
readiness probe,
readiness and startup probe.
startup probe. Okay, so what is the purpose of liveness probe?
It will keep the pod alive, sir.
Yeah, when to restart the pod if any deadlock or something comes, we can decide using okay, so then what is the readiness probe? Like if the pod is ready, then only the service is going to discover that pod. Otherwise, it would be removed from the load balancing. Okay, so then what is the startup probe? If any of the pod is taking more time to start, then better to go for
Startup probes.
startup probe. Then what are the network policies? You want to allow the pods only from the some specific range of IP address, or outbound also we want to configure, or from some namespaces only want to allow. So this kind of requests we can do through network policies. Okay, resource quotas. To the namespaces, we can assign the how many resources they can provision. They don't want to misuse more resources. That kind of quotas we can configure to the namespaces by allocating the resource quotas. Okay, then what is config map? What is the config map? Say for multiple environments, instead of passing multiple YAML files, better to pass them as config maps. If it is a non-sensitive details, we are going to send them as
Secrets.
no, non-sensitive. We'll send them as config
Config
map.
maps.
It is sensitive details. Then we are going to send as
Secrets.
secrets. Okay. So then no one can see that secrets, because here these values, whatever I have given, anyone can see it or not.
Yes, sir.
But if it is a sensitive details, we need to encrypt and we need to send that. Okay. So that we'll discuss in the tomorrow class. Okay. So still try to create a more code. Okay, so try to all these tutorials will have in the Katakoda. If you spend 2 to 3 hours of time, easily we can finish all those assignments. So parallelly do some of the Docker related and Kubernetes related also. Okay, so try to finish. Okay, then in AWS today try to create, everyone need to do EKS cluster. So go to the service EKS and create a cluster. EKS also is nothing but a Kubernetes itself. Okay, so everyone create EKS clusters also. Then we need to work all these in the EKS clusters itself. Okay.
Yes, sir.